EPTA reinforcement is a tool for civil engineers who are working in Archicad and would like to make reinforcement drawings of concrete constructions. It also provides a good opportunity to check the position of placed rebars, meshes, stirrups, and complex elements in 3D. In the beginning, I will show you the main functions of the reinforcement add-on in some slides. Using this tool, we can easily place prepared standard shapes and freeform reinforcement bars. We can automatically insert reinforcements into beams and columns and create a list of applied reinforcement elements. Workflow. In the Model View option, we can set default settings for the whole project. These settings are the diameter and the correspondent weight, the pen color of different diameters for representation in 2D drawings, and 3D model view. On the second tab, we can set parameters for the drawing and text fields. When we would like to place a reinforcement element, first the Object Settings window will appear, where we can select the reinforcement element type, shape, and position of it in the construction, as well as other technical parameters. After we set all the necessary parameters for the element, we can place it into the concrete construction. It is possible to do this freehand or by using the automatic option of the add-on. Of course, we can combine these methods, place some elements by hand and insert others with the automatic option. Next function is a complex element. Complex elements are those that are combined from some different elements for columns, beams, and crowning. After we place the elements, we are able to easily create a cutting list of them. This cutting list will collect all parameters of the selected items: shape, length, weight, and quantity. It is presented in details and summarized in the special table, which can be placed on the floor plan next to the drawings. Here, some drawings are visible, which were created in Archicad using the EPTA reinforcement add-on. Now let's see how we can use it in Archicad, how it can help in our work. After installation, the program appears in the EPTA Solutions/Reinforcement menu in the menu bar. In this menu there is a Load Library, Registration, and a User Manual option. The registration is important because, as with all EPTA solutions, reinforcement also works with an online protection key, so it should be registered before use. The online protection key means while the user is working with reinforcement, their computer has to have an active internet connection. If the connection is broken, the reinforcement license will switch to demo mode. The demo is limited in functions but available for everyone who would like to try it. After registration, we can start working. First, we have to get the toolbar and load the library. It is important because the library is loaded automatically when Archicad starts. When it is done, the reinforcement palette appears. With the tools of this add-on, we can place reinforcements into walls, slabs, beams, columns, and slanted elements like a roof. Let's start with the wall. Let's place reinforcement into the wall. I prepared 3 simple wall combinations. The first is a mesh. I select the walls where I will place the mesh element and click on the wall tool on the reinforcement palette. The settings window appears. On the left side, I select the mesh. On the first tab, I can set diameter, quality, position of mesh, and the 2D representation. On the next tabs, I set table size, table distribution, then 2D appearance, text type, and different labels. In every settings window, there is a checkbox marked Global Settings, and if it is on, the program will use the settings selected in the Model View option. When all parameters are set, I click on OK. Now with this eye cursor, I select which side of the wall I'd like to place the mesh. I click outside on every wall. When I clicked on all selected walls, the add-on asks if I want to place more elements or not. I choose the No More Reinforcements option. The mesh is placed into all selected walls, as we can see. If there is an opening in the wall, it will be cut out from the reinforcement. Check it in 3D. In a wireframe view, all mesh elements are visible in the walls with the holes where there are openings. Back to the floor plan, and I place one more window into this wall. The add-on calculates the new hole in the wall automatically and cuts it out in the already placed reinforcement. I check it in 3D. If I want to add more reinforcements, for example into the other side of the wall, I just select it, click on the wall tool icon, select the reinforcement type with the necessary parameters, and click on OK. With the eye cursor, I click on the inside of the wall, then no more reinforcements. The mesh is placed. Important to know that the add-on will always get information only from the core of the wall and will only place reinforcements into it. This means that the reinforcement will only be placed into the load-bearing construction. Now when elements are placed, I can adjust the position of the 2D views of the mesh. Move it, rotate it, or replace the text and label type and content. If necessary, I can rotate the mesh inside the wall. The rebar works like the mesh. I select all walls where I want it placed. Click on the wall tool in the reinforcement palette and set the position of the rebars. This is important because in the wall it can only be vertical or lateral. I select vertical. On the next tabs, I set all other parameters, like the shape of the rebars, and click on OK. Like in the case of the mesh, the eye cursor appears. I select the necessary side of the wall and click. When finished, let's see it in 3D. Here it is. Now I place one more door into this wall and check it in the 3D window. The add-on calculated a new opening in the wall and reinforcement. Next reinforcement type which I can place into walls is an edge element. It is a complex element which contains rebars and stirrups. I select the walls, click on the wall tool, and I select the rf_edge element from the list. Parameters and position should be set. In a wall it should be vertical. There are no more parameters that can be set. With the eye-shaped cursor, I select the wall side. Let's see it in 3D. It's good and visible that the complex element is placed in all edges of all selected walls, including the edges of openings. Of course, the position and all parameters of the placed reinforcement can be changed. I select it and open the settings window. Now a lot of parameters are available. I want to change the stirrup shape now, which I can choose from the list. But since this element has 8 edges, I can define different stirrups for each of them. The changed stirrup is here and I can see it in 3D. I can change the stirrup in this window. I select the reinforcement element and in the settings window I can change the stirrup type on the other edge, which will be visible immediately. Next, I will show the reinforcement of slabs. There are 3 slabs with the same geometry here. As previously, here we can place 3 different types of reinforcements. I select a slab where I will place a mesh element. and click on the slab tool on the reinforcement palette. The settings window appears. On the left side, I select the mesh. On the first tab, I can set diameters, quality of bars, 2D representation and the position of the mesh. On the next tabs, I can set many other parameters. When all parameters are set, I click on OK. Now with this eye cursor shape, the add-on asks which edge of the slab I'd like to place the mesh parallel to. I click on this side of the slab. I choose the No More Reinforcements option, and here it is in 3D. In a wireframe view, the mesh element is visible in the slab with any holes. If the hole is defined in the slab, it will be cut out from the reinforcement, currently from mesh. The position of the mesh is important. It is now at the bottom of the slab. If I'd like to place it on the top of the slab, I go back to the floor plan, select the slab, and click on the slab tool. There is a button which controls the position of the reinforcement. I turn it off. It's important to set the concrete cover. It can be set anytime. Click on OK and place the mesh. Now to check it in 3D. Now there are two layers if the mesh is placed in the slab. Let's go to the rebar. I select the next slab, where I will place the rebar element, and click on the slab tool on the reinforcement palette. The settings window appears. On the left side, I select the rebar. On the first tab, I can set diameters, quality of bars, 2D representation and the position of rebar. Now again with this eye cursor shape, the add-on asks which edge of the slab I'd like to place the rebar parallel to. I click on this side of the slab. I choose the No More Reinforcements option. Switch to 3D. In the wireframe view, the rebar element is visible in the slab with any holes. If I want to place another rebar, I select the slab again, click on the slab tool again. I select a different diameter and I change the concrete cover. Click on OK. I select the other side of the slab and click. Check it in 3D. Now we can see that two different rebar elements are placed and the defined holes are cut out from each of them. If I change this hole in the slab, the add-on will recalculate the geometry of it and will adjust the reinforcements according to it. Next reinforcement type, which I can place into a slab, is an edge element. I select the slab, click on the slab tool, and choose the rf_edge element from the list. Parameters and position should be set. In a slab, it should be horizontal. The concrete cover can be set for each side. Click on OK. On the floor plan, the different ID appears on edges. I select this element, open the settings window. As it was in case of walls, I can select different edges and define a different type of stirrup for every edge. But if I click on OK, on the floor plan, a new editable hotspot appears. And if I click on this, the local menu comes up. And I can change the stirrups type here. Now in 3D. It's visible that the complex element is placed in all edges of all selected slabs, including the edges of any openings. Also, we can see that I applied a different stirrup on some edges. We just looked at the wall and slab reinforcement, but we did not talk about the listing of elements. So, next is the gutting list. I placed different reinforcement elements previously. Now I select some elements and I click on the cutting list tool on the reinforcement palette. The small list icon appears next to the cursor and I click somewhere on the floor plan. This list contains all selected elements with their ID, shape, size, diameter, quality, and weight. In the end of this table, we find a summarized weight. Now I listed only selected elements, but I would like to add more to this list. I add one more mesh and one more edge element to the selection. Additionally, I also select the list, and click again on the cutting list icon. The add-on will recalculate the quantity of selected elements and will update the content of the list. In the end, I see the list is much longer. It contains more elements. On the bottom of the list, a total weight is visible. If I have several different quality reinforcements, then the weight of different qualities will be summarized separately. The placed cutting list is an object, and if I want to change the order of listed values, I can. I select the cutting list and open the settings window. Here I can change the order of columns or delete any of them if they are not necessary. I can also change the font type, font size, and some 2D properties of it.
A new function of version 5 is the reinforcement of slanted walls. I place the wall combination of slanted walls. I select the slanted wall and click on the wall tool icon on the reinforcement palette. The settings window contains the same settings as in the case of vertical walls. Now I leave all parameters of the mesh and click on OK. I select the wall side where I wish to place the mesh and click. The mesh is placed in the correct position with the selected parameters. Now I place rebars in the other slanted wall. I select the wall, click on the wall tool, and in the settings window I select the rebar element. I leave all parameters in default. I only change the position for vertical. Click on OK, and the rebar is placed vertically in the wall. I click again on the wall tool, and now I set the position for lateral. Then click on OK. The rebar is placed in the other direction in the slanted wall. Let's check it in 3D. As we can see, the shape of the placed reinforcement is correct, even in the wall connection. Of course, edge elements are also possible to place in slanted walls too.
The next tools are the reinforcement of beam and column elements.
The beam tool was implemented into the reinforcement add-on in version 4.0. Now, in this new version, this has been further developed. There is a simple beam element with a rectangular section profile. I select it and click on the beam tool icon in the reinforcement palette. The settings window appears, and as earlier, we can set different views: size of the element, concrete cover, and the element ID. On the next tab, settings of stirrups come up, where it is immediately visible that we have only one group of stirrups. First new feature in this window is the strange yellow triangle, which shows us that there is a collision of IDs. That means that the same ID is set for two different groups. Below, the ID of the stirrup group is set for 1. If I go to the rebar settings tab, we can see that here we have two rebar groups, and the ID of one of them is already set to 1. I change this ID to 3, and the yellow sign disappears. I click on OK and place the reinforcement into the beam element. It's done. Let's check it in 3D. Now I select this complex reinforcement element and open the settings window. I go to the Rebar Geometry tab. Here I can select which group I'd like to modify. As we can see, the IDs of the groups are 2 and 3, as I set it earlier. I choose the group number 2 and change the straight end of it to the once bend. I set the length of this bend part for 100 mm. This modification is immediately visible on the preview picture, but when I click on OK, it appears in the 3D model. But the bend was not done in the right direction. Go back to the settings window, and I can modify the size of the bend to be -100 mm. The direction is now in the right direction. Let me make an undo. Up until now, we could only control this with values and with the plus or minus prefix. The next feature is a special hotspot on the bend. Grabbing this hotspot with the cursor, I can turn the bend in any direction. But it is important to know that the other rebar in this group will be turned to the same angle symmetrically. It means that there is a new option to turn the bend not only in a vertical position, but I'm also able to turn it to, for example, 45 degrees. I want to modify the other rebar pair on the top of this beam. The element is selected, and I open the settings window again. Select group number 3 and modify the geometry of it to the bent up straight end type. I set the bending value and click on OK. In the 3D model, the bending is visible, but once again, it is in the wrong direction. Click on Undo and open the settings window again. Set the bending value for -100. The direction is almost good, but the bend size is too big. I set a little bit smaller value for it. Now it's better, but this was the old method to set a good direction. I click on Undo again. I set the values without a minus prefix, then click on OK. In the 3D window, I can find some purple hotspots for modification on this rebar group. With this hotspot, I can move the bend in the axis direction of the rebar. With the next hotspot, I can change the bend size in 2 directions. With the hotspot in the center of the rebar, I can change the length of the rebar. And finally, with the hotspot on the perimeter of the rebar section, I can turn the rebar to the right position, even in 45 degrees. This turning option was not available in the earlier versions of the program. It gives a good opportunity to define the correct rebar position for many new cases. Okay, let's see the stirrup settings. I open the settings window and go to the Stirrups Settings tab. Here is, as I said earlier, only one stirrup group. But I'd like to have groups with different allocations, so I define 3 groups. The yellow sign appears immediately because the 2 newly created groups have the same ID as the first one. I set different IDs for these 2 groups, and the warning sign disappears. I click on OK. There are no changes in the position of stirrups because I did not set a different distance between stirrups in different groups. I go back to the settings window. On the placement page, I can find all 3 groups in the drop-down list. For the first group, I set the distance at 100 mm. For the fourth at 200 mm. And finally, for the 5th group, I set 100 mm again. There is an option to set the distance of the first stirrup from the end of the beam, which I set for 0 for now. Click on OK. The differences between the 3 groups are clearly visible now in 3D. 100 mm in 2 groups at the 2 sides of the beam, and in the middle the distance is 200 mm. I open again the settings window, and on the Stirrup Settings tab, I change the length of all 3 groups. Clicking on OK, we can see how the stirrup placement was changed. I go back to the floor plan, and what we saw in 3D, we can also find in the 2D representation. In this view, it's possible to change the length of stirrup groups manually with the purple hotspots on the end of them. When I grab this hotspot and move it, the length of the group and the quantity of stirrups will automatically be adjusted to this new size, keeping the distance between stirrups. New features of Column Reinforcement 5.0. In the previous version, we could place the reinforcement only in columns with a rectangular section profile. From now on, there is an option to do the same in columns with a circular section profile too. But this is not the only new feature in column reinforcement. I prepared 3 columns. 1 is with the rectangular profile and 2 are with circular. Let's start with the rectangular. I select it and place the reinforcement in it. The global settings are set for this column, and I left everything in default. Click on OK. The reinforcement is placed in the element. I select the reinforcement and open the settings window. On the first tab, as usual, I can select the views of it and its concrete cover. On the next tab, the stirrup settings appear, where I can see that only one group is defined. This group has the ID number 1 and the yellow warning sign appeared. It is here because there is a collision of IDs in this element. I move to the rebar settings tab and we can see that one of the two groups of rebars has the same ID as the stirrup. I change it to number 3 and the warning sign disappears. I click on OK. Then check the selected reinforcement element in 3D. The element contains 4 rebars in 2 groups and stirrups. I select the element and open the settings window again. On the geometry page, I can change the shape of the rebars of group number 2 to the once bent end on the top of the column. The bending size is too big. I set a smaller one and click on the OK button. As we can see, there is one bend, but it is in the wrong direction. On the bent part, there is a new hotspot, and with this hotspot, I can turn the bending to the necessary direction easily. Of course, the other rebar, which is in pair with the first one, will be symmetrically turned too. With a hotspot on the end of the bend, I can make this part smaller or larger manually. All changes on this rebar will be repeated symmetrically on the second rebar. Let's change the other rebar group. I open the settings window. On the geometry page, I select the second group and all parameters of this group are visible. I change the shape of rebar end from straight end to bent up straight end. Size of the bend is too big, I set smaller values for it. Clicking on OK, the bend appears immediately. With the hotspot in the center of the rebar section, I can make it longer. The hotspot in the corner of the bend lets us move the bending stage up or down. But I see again, the direction of the bend is wrong. With the hotspot on the perimeter of the rebar section, I can turn the rebar to the correct direction. The second rebar in this group will be turned too, but of course symmetrically. With this method, we get a much better solution for creating column reinforcement continuity. Of course, the simple bent rebar can also be stretched longer with the hotspot defined in the corner of the bend. Okay, let's see the settings of stirrups. I leave the reinforcement element selected and open the settings window. On the stirrup settings tab, we see that only one group is defined with ID number 1. If I define 2 more groups, the yellow warning triangle appears on the right side of the window. It means there is an ID collision in the reinforcement. One or more elements have the same ID. We can see immediately in this window that all defined stirrup groups have the same ID now. I had to change them, so for the 2 lower groups I set number 4 and number 5. The ID collision has been fixed. The warning triangle disappears. Now I move to the Placement tab, and in the drop-down menu of Groups, new IDs are visible. Now I set the stirrup distance for the first group to 100 mm. This modification is immediately visible in the preview window. I modify the distance in the 2 other groups too. Returning to the stirrup settings window, I change the stirrup group's length. And I click on OK. In the 3D model view, all changes are performed. Let's see now the circular section column. I select these 2 columns and place the reinforcement into them. The settings window opens, and without any changes, I click on the OK button and finish the operation. Reinforcement is placed in both elements, and as we can see, with the circular stirrups. I select the placed reinforcement complex element one by one and set different IDs for them for easier identification. Let's check them in 3D. These two are the same elements with circular stirrups and with two rebars. Go back to the floor plan, select only the second one and open the 3D view. It seems there is only one rebar group with two rebars. I go back to the floor plan, select the reinforcement and open the settings window. On the first tab, as usual, we find the view option of the complex element and the concrete cover value option. Next is a stirrup settings page. On this page, we can see that there is one stirrup group defined with ID number 1 and the collision warning appeared again. On the next tab, the stirrup geometry can be set, and for this column, a circular stirrup is selected from two predefined types. On the rebar settings tab, I find that the ID of the two rebar groups is also number 1. I change it to number 3 and the warning sign disappears again. I click on OK and close the window. Now we see the 2D representation of the reinforcements on the floor plan. If I grab one of the rebars with a hotspot, I'm able to rotate it around the center of the column. It seems like I rotate both rebars to the other position, but when I click on that other position, it is visible that there were two groups of rebars covering each other, so one rebar group stayed on the original position. We can check it easily in 3D, where we can see it pretty well. I select reinforcement in this view and open the settings window. I go to the rebar geometry tab. On this page, first I select the number 2 group of rebars. I change the shape of the rebars in this group from straight end to once bent end, and put the smaller size for the bend. I click on OK. Two rebars, which are in the same group, have been changed. The bending of rebars will always turn to the center of the circular section of the column. With the hotspots, I can stretch the rebar longer, or with the other hotspot, change the length of the bent part. As with rectangular columns or beams, all rebars in this group will be changed symmetrically. I select once again the reinforcement complex element and I change the length of the other rebar group. On the end of the rebar, I see two hotspots. With a hotspot in the center of the section, I can stretch the rebar, and with the hotspot on the perimeter, I can rotate the rebar around the center point of the column. I open the settings window. Now I will change the geometry of the other group. So I select group number 3 from the drop-down menu. I change the shape of the rebars to the bent up straight end and set a smaller size for it. The direction is wrong, but with the hotspot on the bent stage, I'm able to turn into the right direction. Now let's see the other circular column with ID number 3. I select the rebar and open the 3D window. Like in the case of the previous column, only two rebars are visible. But in the settings window, we see two groups. I grab the rebar hotspot and turn it to 90 degrees, and this group of rebars is turned to this position. Now we really see two groups of rebars. In the 3D window, I select the element and with the center hotspot of rebars, I make them longer. On this model, we can see that the stirrup is circular. I open the settings window and select the Stirrups Settings tab. The yellow warning sign is visible, so there is a collision of IDs. On the Rebar Settings tab, I changed the ID of the second group to number 3. Warning sign disappeared. I move back to the Stirrup Geometry Settings tab. And here from the drop-down list, I select the new spiral stirrup type and click on OK. In the model view, the spiral stirrup is visible immediately. As with the circular stirrup, it is possible to define some groups. I open the settings window and move to the Stirrup Settings tab. I define 3 groups. The yellow warning sign appeared again because new groups have the same ID as the first. I set other IDs for these groups. When it's done, I move to the Stirrups Placement tab and set a different distance for each group. When I change the value, it is immediately visible in the preview window. I finish it and click on OK. All 3 different groups are visible clearly, and the spiral rise height corresponds to the set value. I go back to the floor plan. The last step is the cutting list. I select the reinforcement of the rectangular column and click on the Cutting List tool. Then I place the list on the floor plan. Now I select the reinforcement of the circular column number 2 and click on the Cutting List tool again. Then place the list next to the element. We can see that all elements of the column's reinforcement are listed separately. I modified the list separator border a bit because there is not enough room for the rebars view. And lastly, I select the reinforcements of column number 3 and click on the Cutting List tool again, then place the list next to the element. Here the spiral stirrup is listed as one piece in each group and the full length is indicated. I now delete these 2 groups and I select the reinforcement of the first and second columns, then the earlier placed list. Click on the Cutting List tool icon. The existing list is updated and all elements of the 2 columns are listed together. I now select only the list and click on the second icon of the Cutting List tool. The program shows me which elements were listed in this list and selects them. I add the third column's reinforcement to the selection and the list, and click again on the first icon of the Cutting List tool. The cutting list is updated with all parts of the 3 columns. New dedicated layers in Reinforcement 5.0. Up until now, when you place the reinforcement into the building elements, you could place them on Archicad default layers, or you had to create a new one manually. This has now been changed, and when you place a reinforcement, a new dedicated layer appears and the element will be placed on it. There is a default layer structure. Let's start with the slab. In Archicad 26, all layers are grouped by different criteria. Now I select the slab element and as we can see, it's a simple slab. I will place the mesh into this. Clicking on the slab tool on the reinforcement palette, the settings window appears. By default, the mesh element is selected in the library. Of course, I could select any other element, but now I leave the mesh. On the bottom of this window, the layer selection is available, where we can already see a layer called Reinforcement Slab. This layer was not available earlier, and as we can see, the new layer group was created automatically. The new layer, of course, is placed in the new layer group. I click on OK and place the mesh in the slab. Now I once again open the layer settings window. In the layer group part of this window, the reinforcement folder appeared, and clicking on it, the new reinforcement slab layer is also visible. The next is a wall. I select it and click on the wall tool icon. The settings window is opened, and on the bottom side of the window, the new reinforcement wall layer is already available. Continuing the operation, the mesh is placed in the wall. When I select it, on the info box palette, the elements layer is already the reinforcement wall. Let's check the layer settings window again. The reinforcement wall layer was created in the reinforcement layers folder. The next is a beam. I select it and click on the beam tool icon. A new layer is created, which is called reinforcement beam. Click on OK and place the reinforcement of this element. In the layer settings window, one more new layer is visible. I did the same process with columns. I select it and click on the column tool icon. The rf_column element is set, and the new reinforcement column layer is created. And finally, the roof element. I select the roof and click on the roof tool icon. In the settings window, the new layer is already visible, and I can choose any of the reinforcement elements. All of them will be placed on the new layer. Now I select the mesh and click on OK. I place the mesh into the roof. Of course, as with all previous layers, this layer is created in the reinforcement layer folder.
Custom shape rebar. Next is the construction when the standard rebar is not enough, and we need to make a special reinforcement. The best sample for this is the stairs, because stairs have a very flexible shape. We cannot place automatically the straight, horizontal or vertical reinforcement. We have to use a polygon rebar for it. Here is a very simple stair. Let's check it in 3D. Let's see how I can place reinforcement elements into this. I will place everything manually. There are some simple rebars already placed, but now I will place custom rebars into the inclined stair. In the reinforcement solution, I can select the special rebar. I select it and we can see that it is not a standard element. I open the settings window for it. On the Geometry tab, I can select the polygon option from the list. Next to this, the new option appears where I can define the editable hotspots number on this element. I will now show how it works. Let's place the new polygon rebar. Open the settings window, select rebar, then on the first tab, the single rebar. On the next tab, I select the polygon type and click on OK. I place the element. I select this rebar and editable hotspots appear immediately. I'll go back to the settings window and switch off the label. Now I can change the shape of this rebar. I can make the straight part curved, or I can add new hotspots to this section. It shows that almost any shape is possible to create. I did the same modification of the rebar, I just adjusted points of it to the stair geometry. Now to see it in 3D. There are straight rebars on the horizontal parts of the stair, and here there are slanted rebars. And I can list all placed elements with the cutting list function. I select all placed reinforcements and click on the cutting list tool. Then I place the list next to the drawing. If you have any questions, please send it to us. Thank you for your attention.